ऑनलाइन हो गया? ये आवाज कैसी आ रही है? हेलो, हेलो टू ऑल द स्टूडेंट्स। अभी सही है। आई एम जीपी सिंह and we are going to discuss physics for class 11th based on HC Verma's book Concepts of Physics. So the students who are following HC Verma book may also follow this class. There are many books, NCERT books and other books also there being taught in different schools, but this class is based on HC Verma's book. Fact is that in this book there are so many chapters like Introduction to Physics, for which I have already taken 1 or 2 lecture. Another chapter is Physics and Mathematics and Rest and Motion. These classes, Physics and Mathematics and Rest in Motion, I have already taken few days back, I think some 15 or 20 days back. You can search it on the app on which we are online at present. So I think no need to again give lecture on that chapter. So today we will start the chapter number 4, that is the forces. As I have already taught you that in physics we are dealing with so many natural phenomena, and one of the big part of physics is force. Whatever is the curriculum of physics, in any book, any chapter, in any book or in any stage, a large chunk of it is based on forces. Force, in general opinion, is simply a factor which can perform any work. You can push anything, or you can pull anything, or you can apply force to any device to get some sort of physical movement or physical result. You can put a hammer and with force you can hit something and get it broken, or you can hit a nail in the wall. These are all routine example of force. But there are a lot of other forces, like you drop a ball from the 3rd floor ceiling and it comes down to the ground. There also is a force, there also a force is involved that we all very well know is gravitational. Force. Or you can connect a fan with electric current sockets, make supply on, and you will get the fan moving with high speed or high velocity or anything you can say, and you will get stream of air towards any direction where you desire, to your body or anywhere else. Or you can connect the same set of wire to any bulb and you can get the light. That also is an example of electric force, of work done by electricity, right? So wherever some work is being done, force is there. Without force, you cannot expect work to be done. Here we have seen some examples like putting nail in the wall or in the wood, coming down of the ball, cricket ball or any ball or any object being dropped down from height to the ground, or any electrical appliances being run by the current, electricity. So these are all forces. Sometimes you, while you play with so many toys, you may find a magnet. It may be of any shape, and with the help of magnet, you must have played in your childhood. You can pull any metallic object towards it. Or if there are two magnets, you can feel how they attract each other and sometimes how they repel each other, force each other away from their position. That also is a sort of force that is called magnetic force, right? Or you must have known or must have read or even must have seen any video or any TV program or any video clip where water from height falls and it is being converted with the help of a dynamo, where the dynamo is being rotated to create the electric current, where the potential energy or potential force is being used to rotate that dynamo, and in turn, with the help of dynamo, electricity is generated, and with the help of electricity, again, you can do a lot of things, a variety of things. So these are all examples of force in nature. Falling down of water from, mostly found in hilly areas, in mountains. These are all examples of force. So these are all examples of force. Actually, let's discuss about gravitational force. In the whole universe, let us discuss gravitational force first. In the whole universe, or if we cannot imagine the total universe, we can imagine our solar system, sun, earth rotating around it, and moon rotating around the earth. And you may consider or you may imagine other planets also, like Venus, Saturn, Jupiter, etc. Rotating around the sun and also exerting force on other planets. You might have heard about the pull by tide, tidal pull by moon of sea water. सुना है इसके बारे में कि on full moon day, when there is a full moon is of full size, the sea water start moving towards earth, and it is suppose that it is pulled by the gravitational pull of moon, right? So in gravitational force, what is the basic theory? Basic theory is, suppose one particle is there, it may be very small or it may be very big, consisting of numerous number of small particles. The true nature of force between these particles is every particle attract all other particles, and all other particles attract this particle and rest all other particles. Suppose this is a big piece of rock, बड़ी सी चट्टान है. You can consider there are small granules. This rock is consists of a lot of thousands and millions and trillion number of small particles. Each particle, one particle is here, it is pulling all other particles, and one particle is here, this particle is also pulling this one, and this particle is also pulling this one and rest others. This particle also pulling this one and rest of the particles. Right? Simultaneously, the whole rock or each individual particle in this rock is also attracting the another rock. Each particle in this rock is attracting each particle of this rock, and in totality you can say that this rock attract this rock and vice versa. Likewise, every object, whether it is living or non-living, attracts each other. This is called universal gravitational attraction. The only condition is any particle should have a mass, and mass varies from where to where? Mass varies from electron to, you may consider a small piece of material, but again this small piece of material may be divided into millions numbers of molecules, and molecules can further be divided into few number of atoms, and atom is again supposed to be consist of proton, neutron, electron and few other particles, in which electron is supposed to be smallest. It may be not smallest, but it is one of the smallest. Still it is having a mass, though you cannot imagine how small is this mass. Huh? So the mass of any particle in this universe, or in the setup which we are living, in our room, in our colony, in our house or in our city, it varies from electron to the mass of whole earth. Whole mass of whole earth acts in a single nature mass. You might have heard about center of gravity. Through center of gravity, for an object, suppose this table is here and it may consist trillions of particles, but for an object far from its location, it will attract it, being a point mass, through the and it is supposed that its whole mass is condensed on its center of mass, or geometrical center, whatever is you can say. And for remote object, it may the remote object may feel that one single mass is being acted upon it, is being attracting it from one point. This is called center of mass or center of gravity or geometrical center of this object, right? So this is nature of gravitational pull or gravitational force. There are few things which is useful to mention here, that force is always a vector quantity. Force is always a vector quantity. Why it is needed here to say? We are discussing that a lot of force is there, one object and another object, and we are saying that each particle of this is attracting each particle of this. So there may be innumerable number of force towards this. All that forces are summed up in a vector form to get a resultant force. And also, being a vector quantity, it will have a well defined direction. Magnitude is there, but also there will be a well defined direction, which is resultant of the magnitude as the direction will be resultant of vector summation of all the forces acting in this body towards another body. Vector addition, you might have studied, in which magnitude and direction are being added in a particular manner. Right? So, another important point is Newton's third law. Newton's third law of motion. What is the Newton's third law of motion? If a body, suppose I am pushing a body, if a body exerts a force on another body, the another body exerts exactly equal and opposite force on the first body. Suppose A is putting a force on B, which is F. The B is also putting a equal and opposite force, which may be called minus F. Minus F means same magnitude but opposite direction. Vector quantity studied, that minus vector is equal in magnitude but opposite in direction. Is that okay? So, these things are always being kept in mind while discussing the nature and behavior of force. Suppose two magnets are there. Sorry. Two bar magnets are there and are kept in this manner, such that their similar poles are facing each other and another set of similar poles are kept away. This will try to push it away. This will also try to push it away. Their magnitudes may be different. Their intensity of their magnetic powers may be different. They may not be same. This may be a bigger magnet. This may be a smaller magnet. It is a general statement. Or they may be equal also. But the force acting on each other will be a resultant force, and that will be in such a manner that whatever force, repulsion force, this is exerting on this magnet, an equal and opposite force will be exerted by this one to this magnet in opposite direction, and the resultant will be both of them will move apart from each other, move away from each other. Right? This is the simple example of Newton's third law of motion. Right? Now, So what we have found, there is a very basic law, that is actually natural law, which tells magnitude of force between two particles having mass. This is called universal law of gravitational force. Universal law of gravitational force, and it is written as F is equal to G m1 m2 r square. What does it imply? What does it mean? It means that the force, that is gravitational force, here we are talking about gravitational force. Suppose there are two particles, maybe small point objects or maybe big. In small particles, the whole mass is supposed to be concentrated on this small point, and in bigger particles, the whole mass is supposed to be concentrated on its geometrical center or center of mass or center of gravity. So they may also interact with each other as a point mass. So if we want to calculate the force between two objects being kept at a distance of r meters apart, we can find in its value of force with the help of this formula, where m1 is the mass of one particle or one object and m2 is the mass of second object, and they are kept at a distance r. This is also called inverse square law. Inverse square law. Inverse square law means the inverse part of this formula is not a single power, it is square in nature. So this is a very general formula, but it is very useful formula. And the nature of this formula is such that it is used in few other cases also, where gravitational force is not involved, like electric and magnetic and other forces are involved. In that case also a similar formula is being calculated. So when we study the next few chapters, we will find that the electromagnetic force, electric force and magnetic force also following more or less the same pattern of behavior like gravitational force. But there is a little difference. In nature, the gravitational force is always attraction, force of attraction. Gravitational force. But electric and magnetic force may be of attraction or repulsion. Same is the case with magnetic force, right? So when we talk about force, it is found there are certain categories of forces, and a lot of forces there. They can be put in one category or another category. In general, there are 4 categories of forces. What are these categories? First is gravitational force. Another is electromagnetic force. Third is nuclear force, and fourth is weak force. Fourth is weak force. Gravitational force is responsible for simple attraction. All the things are located on this earth, situated on this earth in different points, in different position. That is only because of gravitational force. Without existence of gravitational force, there would have been complete chaos. ग्रेविटेशनल फोर्स के कारण सब चीजें अपनी जगह पे टिकी हुई हैं, रखी हुई हैं, इधर से उधर नहीं भाग रही हैं. आपने देखा होगा कि वो जो टीवी वगैरह में वो चलाते हैं, दिखलाते हैं न्यूज या कोई और प्रोग्राम चलाते हैं कि स्पेस शटल में या स्पेस स्टेशन पे जो स्पेस अंतरिक्ष यात्री होते हैं वो आराम से इधर उधर जाते रहते हैं और उनको कहीं से कोई खिंचाव नहीं लगता है, वो उड़ते हुए जैसे चलते हैं. या कोई सामान भी रहता है तो उसको यूं कर दो तो बस वो चलता जाता है. ये दिखलाया होगा. तो वहां पे ग्रेविटेशनल फोर्स नहीं है. अब वैसे सोचो कि अगर अर्थ में भी ग्रेविटेशनल फोर्स ना होता, धरती का खिंचाव ना होता, तो सारी चीजें यूं यूं घूमती रहती हैं, आपस में टकराती रहती हैं, इधर उधर जाती रहती हैं. तो ऐसे तो पूरा जो है क्यास हो जाता, पूरा अराजकता हो जाती, कोई चीज कुछ ना रहता. मैं यहां पे खड़ा हूं तो इसका मतलब अर्थ हमको खींच रहा है। या उसका कुछ साइड इफेक्ट भी है कि अगर कोई चीज ऊंचाई से गिर गई तो फिर गिरा तो फिर मरा, अगर कोई आदमी गलती से ऊंचाई से गिर गया तो मर गया। तो कुछ तो उसका साइड इफेक्ट भी है। अगर वो ना रहता तो गिरता तो मरता तो ना, लेकिन मरता ना, लेकिन फिर उसके बाद पूरे धरती पे पूरी अराजकता हो जाती। ठीक है। अब दिस ग्रेविटेशनल फोर्स acts from smallest of the smallest object to the biggest of the biggest objects, and in between smallest object and the biggest object also. You might have heard that if earth is pulling me, I am also pulling this earth towards myself, my body, my physical body having a mass. So this is always an force of attraction. Another force is electric and magnetic force. You know the electric force is there. Electric force means with the help of electricity you can perform a lot of work, mechanical and so many things. Even a mechanic use grinding machine is there, and drilling machine is there, like so many uses of electric force. And magnetic force is also there, but these are interrelated. An electric wire carrying alternative current AC may behave as a magnet. You will read in another chapter. So it was found that electric and magnetic forces are sometimes very similar to each other, and they are interrelated also. A magnet can be used to produce electricity, or an electric a wire carrying electric current may be used as a magnet. So these two, electric force and magnetic force, are found to be quite interrelated and sometimes quite identical with each other. So they were categorized in one type of force, and they were simultaneously called electromagnetic force, right? Another is, these two are having small to very big magnitude. Correct. Now comes the nuclear force. Nuclear force is the force existing between various nuclear particles. You know that there are, everybody knows there are electron, neutron and proton. Very interesting thing is that electron and neutron are having opposite charges, charges, and the action reaction between proton-proton, proton-electron, and electron-electron. Neutron, being neutral in nature, does not get involved in the electrical attraction or repulsion process between other nuclear particles. So the force between electron and proton is also electric in nature. Electric in nature, and this also follow the same formula of force of attraction. What is that formula? The same. Force is equal to one constant m1 into m2 divided by r squared. But this force is not being categorized in electromagnetic force, because its magnitude is very low, and it is visible or observable only because of its aggregation. Aggregation means the force between two particles may be of the order of 10 to the power minus 16, but there may be but the number of particles may be 10 to the power 24. Yeah. So when being aggregated, each and every force is being summed up, then it is multiplied with this, and the result may be 10 to the power 8. Because in multiplication of powers of 10, the powers are simply added algebraically, right? So 24 minus 16 may become 8. That is the power of aggregation. Like very small particles aggregated to a big stone. This is called aggregation, right? So, my dear students, nuclear force, they are telling the volume of it is about 10 to the power minus 23 meter. That is beyond your imagination, because 1 millimeter is only 10 to the power minus 3 meter. 1 millimeter is just like this much, or tip of this pen, and it is 23 and 10 to the power 20 times smaller than 1 millimeter. So like this, another force is weak force. This is also a different category of natural force, at par with the gravitational force, electromagnetic force, nuclear force. And fourth is weak force. Fourth means it is not at fourth position, it is one of four, right? This is observed in beta decay or beta plus decay. This is out of scope of this book. Just know the name and where it is involved. Nothing more is going to be discussed at this level. So, mainly gravitational force and electromagnetic force we will study at this level. And one of the important point is we will, in most of the cases, we will follow the inverse square law of force to calculate the magnitude between two particles, whether they are mass particles, electric charge, or magnetic poles. We will always follow this inverse square law, where force is equated to one constant and two m1 m2 or q1 q2, and this distance is always common. Here it may be m1 m2, q1 q2, or magnetic pole strength, right? This is the whole essence of this chapter. I hope you will go through the book provided with you, and you will study few more points left not worth discussing in the class, and you will come up with any questions if it arises in your mind. With this, I am concluding this class today, and on Monday we will again start the Newton's law of motion. It's okay? ठीक. हरिओम.